Web3D is a blanket term which is used to describe any sort of application or component of 3D graphics which runs in a web page. So basically you would click on a link in a web page and that would take you to another page which would have some sort of 3D graphics running. Previously, to have 3D graphics running inside your web browser, you needed to have some sort of plugin installed in that browser. But now with the advent of WebGL technology being supported in all major browsers, we can look forward to a time when 3D graphics applications are running natively in every single browser, whether it's Internet Explorer or Firefox or Chrome.
Developing web application right now is very, very easy. You have a good set of tools and libraries that have been tested in production environments for a very long time. But on the other hand, if you want to do a 3D web application, we are still in a very early stage. The technology is not very fully developed, but we are confident that that's going to change in a very short time.
Fundamentally, there's not much difference between standard 3D graphics and Web 3D graphics. The biggest difference is that Web 3D graphics are running in your browser and you access them by typing in a URL or clicking a link in your browser. There are a few restrictions on the actual application. Browser-based 3D graphics generally are a little bit constrained as to what they can do compared to native graphics applications. But perhaps the biggest challenge is the distribution of content and assets for 3D applications. They're usually quite large file sizes, and of course that means you have to download them over your internet connection every time you're accessing them via the web. Another disadvantage of using web-based graphics is that you're relying on programming in JavaScript. On a technical level, JavaScript is a little bit slower than the native code that you might write in C or C++. And so when you're writing a web-based 3D application, you have to be very careful to bear in mind the limitations that are present by using JavaScript. There are several approaches for creating a 3D graphics web page. Perhaps the most common approach these days is to use a software API called WebGL, which is essentially a web-based version of the famous 3D API OpenGL. And WebGL essentially allows you to, at a very low level, program 3D graphics applications in a web page. But it's true that to program in WebGL, you need to have quite a strong background in 3D graphics and quite a strong knowledge of programming techniques. And so there are several approaches that make it a little bit easier, particularly for web programmers, standard HTML and JavaScript programmers, to create 3D scenes. Some of these higher level techniques include technologies such as X3DOM or XML3D, which define an XML namespace and allow the programming of a 3D scene in a more traditional declarative manner. And there are also several proprietary solutions like Unity 3D or Java, which do require a plugin, but allow 3D graphics to be embedded in a web page in a different manner. And the advantage of this is you can create your 3D application in a separate, distinct package dedicated to the task, and then deploy it onto the web.
3D web applications won't replace the classical 3D applications that we are using right now in our current pipelines, but we are confident that those new 3D web applications could complement them beyond the simple 3D biowares that are being used right now. So we are confident that in the near future we are going to see 3D web applications in fields like medical visualization, data visualization, architecture, or even video games.
Here at the GTI at Universitat Pompeu Fabra in Barcelona in Spain, we've been working with web-based 3D graphics for quite a while now. A few years ago, we did the official MMO game for the Barcelona World Race, which featured 3D graphics on the web. And also in 2013, we won the best paper at the Web 3D conference in San Sebastian in Spain, which is the standard reference conference for 3D graphics on the web and has been for the last 20 years. We're currently working in a European project, a European FP7 project called IMPART, where we're taking advantage of the 3D data that's being recorded in production and post-production scenarios. And we're researching now new technologies and new ways of visualizing that data in a production set, in a post-production environment. So where do we go with the future? Well, now that all the major web browsers support WebGL natively, there's no need to install a plugin The sky really is the limit for creating 3D web applications. And here at the GTI, we're looking forward to seeing where our research takes us.